This is the transformer rectifier. This is 50 volts, 50 amperes output. Okay. So presently the transformer rectifier is off. It is installed with ECT transducers. You can see. Hopefully it's visible. Okay. It is internally connected to this DIN rail. So from this point we are giving connections to our SCADA communication. So these are the cables going to voltage. This is the DC volt. These cables will give you the approximate milliamperes for representing the DC voltage. And these two cables will give you the approximate DC amperes. Okay, this has to be connected to process meter. This is our process meter. Okay, process meter, it should always be connected in loop power mode. This is the positive cable. Okay. This is the negative cable. Okay, and the same thing we have to do for the current. Okay, these are the current cables we are coming. It is going to this point and it is going here. This is connected to process meter and the loop power mode. So now we need to turn on the TR. Before turning on the TR, I just turned on the process meter. So now the TR is off. The process meter shows me 4 milliamperes in one. This is the voltage, this is the current. So this indicates my ECT is working. If my ECT transducer is not working, now the TR is turned on. Okay, it is operating at approximately 9 volts, you can see, and approximately at 9 amperes. The shunt rating of the TR is 50 millivolts, 75 amperes. Okay, the same thing we can see it here. This is 9.6 volts, and here you can see 6.4 millivolts. These are the two formulas that has to be taken care when calculating the milliampere approximately. For 50 volts TR, the first formula will come effective V plus 12.5 divided by 3.125. Okay, this is for voltage milliampere conversion in the process meter, and the lower one is 50 above. This formula will come into picture. This is V by 2 plus 12.5 whole divided by 3.125, and for ampere conversion, MV plus 12.5 divided by 3.125. This millivolt values are irrespective of the shunt ratings. Now the shunt rating what we have in the TR is 50 millivolts, 75 ampere. So we don't consider this one. We just take the values what is measured across it. This is 6.4. So while calculating, we'll consider 9.6 volt and 6.4. So the first calculation will be 9.68 plus 12.5 equals divided by 3.125. This is equal to 7.1 milliamperes. This is the readings we need to get at the process meter for the voltage, and the same one what we are getting in 7.01 approximately. Okay. For current also, the millivolts what we measured is 6.4. 6.4 plus 12.5 divided by 3.125. So 6.048 we need to get in the current transducer output. And the same we are getting here, 6.046. One important consideration that needs to be made here. This is the these formulas what I showed you is for